In this video, we're going to be doing the types of reactions lab in the event that you weren't here, or if you just want a refresher as to what was going on. So we're going to do basically one or two of each type of reaction that we learned about the other day. Those types include decomposition, which is when one thing breaks apart to two pieces or more. Synthesis, when things come together to make a larger product. Single replacement, where one substance replaces another one in a compound. Double displacement, where two things swap partners. And combustion, where you have something reacting with oxygen in the air, typically a hydrocarbon, making carbon dioxide, and water. So the first thing we're going to do is a couple synthesis reactions, one involving copper metal, and then another involving magnesium ribbon. So first, I'm going to ignite my Bunsen burner. In order to get metals to react with oxygen in the air, sometimes you have to add a decent amount of energy. If you look at the piece of copper first, you can see that it's a little bit shiny, metallic looking substance. And now when I put it in the tip of the inner cone of the flame, it's going to get quite hot, and it's going to start reacting with the oxygen in the air. After a couple minutes of this, you'll be able to see that it's completely changed color, but for now, I think that should be good enough that you can see a difference. Now you can clearly see that it is no longer the same shiny substance, and that it's oxidized to form copper 2 oxide. This is magnesium ribbon. Pause. So now I'm going to insert the magnesium ribbon into the flame. At the tip of the inner cone of the hottest part, you'll be able to see the reaction. When I'm doing this in person, you would not look directly at the flame, as it releases a very bright light. Now that it's done, you can see that it is completely different than the shiny silvery metal that we had before, and it is a white, powdery, brittle substance called magnesium oxide. In this next demonstration, what I'm going to do is I'm going to heat copper carbonate, which you can see here is a nice turquoise color solid, and I'm going to, when I heat it, it's going to decompose to produce carbon dioxide. And one of the ways we can test for carbon dioxide is that we know that it extinguishes a flame. So what we'll do is, once we get the reaction going and the carbon dioxide builds up inside the test tube, I'm then going to insert a wooden splint that's on fire into it, and we'll see that it douses the flame. So I'm going to get that going, and then we'll resume. So you can see that as I heat this, I'm pointing it away from anybody else, and I'm not putting the metal test tube holders in the flame. And you can clearly see that it's basically going from that nice turquoise color to a black compound called copper oxide as it is decomposing. So I'm going to keep this going for another minute, and then I should have produced enough carbon dioxide that it'll give me the desired effect. So I'm going to place this right here for a minute. Shut this. I'm going to grab a glowing burning splint. I'm going to insert it in here, and you'll see that it douses the flame, thus showing that we did in fact produce carbon dioxide. In the next reaction, what we're going to do is we're going to put some zinc metal into some hydrochloric acid, and we'll observe a single displacement reaction where we produce hydrogen gas and zinc chloride. So I'm going to add the zinc to here. Since one of the products is going to be hydrogen gas, what I'm going to do is collect it, and then I'm going to ignite it, because hydrogen's flammable and it's fun. So you can see the appearance of the zinc before I add it, and you can see that this is a clear colorless solution. Once I add it, you can start to see the bubbles forming almost immediately. And now I'm just going to trap those bubbles for a minute, and then I will ignite the resulting product gas. Pause. Wait. So now we'll ignite the hydrogen gas. Just a fun little bubble right there.
Go.
Here we have a solution of copper chloride, which is nice and turquoise, and what I'm going to do is I'm going to add some aluminum metal to it. You can see that the aluminum metal is a bit shiny. Drop it in there, and you're going to see that in the next couple minutes it's going to start turning into a completely different color. Pause. Now when we look at the aluminum after a few minutes, you can see that there's a reaction occurring there, and you can see the solid copper depositing at the bottom of the test tube. Now for the next reaction, I have added some zinc acetate to this test tube. It's a clear colorless solution, and I'm going to add some sodium phosphate to it. This will result in a double displacement reaction or double replacement reaction, and clearly you can see that a solid formed immediately. That white precipitate is a solid that's now suspended in the rest of the solution, and eventually will settle out over time and would be able to be filtered from the solution. So, double displacement in the solid that forms is zinc phosphate. Reaction, I'm going to do a demonstration of a combustion reaction where I ignite some ethanol, which has the formula C2H5OH, and I'm going to react it with the oxygen in the air, and the products for any combustion reaction are going to be carbon dioxide and water. That smiley face got pretty ruined.
Happened to me too.
I wake up in the morning, that's what I do.